So, we've got used to doing the trig equations, obviously. This is A-level maths, we're going to make it much harder. So, we're going to learn a couple of equations. So, this is a nice equation. Comes from the triangle. If you have a unit circle, so this is radius 1, and this is an angle x, then this side is sine x, and this side is cos x. If you do mechanics, you'll recognise that straight away. And then, good old Pythagoras, sine x squared plus cos x squared is 1. The nice way of writing sine x squared is sine squared x, but that means the same thing. And the nice way of writing cos x squared is cos squared x. Now, you're never really going to use it in this particular form. What we're going to do is use sine squared x is 1 minus cos squared x, and sometimes we'll use cos squared x is 1 minus sine squared x. I know it's the same thing, but these are the forms that we're going to use it in. Now, I'll say this, but I'll end up saying it again. Sine x does not equal 1 minus cos x. Okay? And cos x does not equal 1 minus sine x. It's sine squared x is 1 minus cos squared x. Cos squared x is 1 minus sine squared x. It comes from Pythagoras. It's all about squares. Don't do that. No, do not do that. Okay, 3 formulas. That's 2 of them. It's only 1 really, but it's 2 if you remember it like that. Sine squared is 1 minus cos squared is 1 minus sine squared. And the last formula, sine x over cos x is tan x. Now you can just remember it, but it's very easy to prove. If we have a triangle, this is the opposite, this is the hypotenuse, and this is the adjacent. Sine x is the opposite over the hypotenuse, and cos x is the adjacent over the hypotenuse. So if we times the top and the bottom by h, by the hypotenuse, then you get O over A, which is tan. So very easy to remember that one. Sine x over cos x is tan x. So, shall we go at using them? Yeah. Here's a nice equation. Don't think we even need to use it for this one.
No, that looks like quadratic to me.
Can you factorise it?
I think so. Well, I hope so anyway. So we're going to get sine x. Sine x, I think it's plus 1 and minus 3.
Yeah, I agree with that.
0. So we're going to get sine x is 3 and sine x is minus 1.
Yeah, this one's impossible, isn't it? Sine x is 3, because the graph of sine x looks like this, and the highest it ever gets is 1. So 3 is up here, it's never going to equal 3.
No.
So this is NA, or no solutions, or impossible. Don't just ignore it, because the examiner wants to see that you understand, that you've looked at it, but you could write impossible or no solutions, and then that shows that you understand.
This one though,
Sine x minus 1.
certainly hits it once, doesn't it?
Yeah,
Between 0 and 360.
Yeah, it's this one here.
Yeah.
I mean, to be honest, I don't think we even need a calculator, do we?
No, it's 270.
Yeah, halfway between. Yeah. Yeah. I mean, we could inverse sine minus 1.
Yeah.
But it's obvious from the graph what it is, really obvious.
Yeah.
And we only want to be between 0 and 360, and you can see there's only one solution by looking at the graph. So, yeah. I mean, if you did want to check on your calculator, then you can obviously option calc, solvent, sine x equals minus 1, and just check that it is the only solution. This one?
That's another factorising, isn't it?
Yeah, common factor.
So, sine x is a common factor, we're left with sine x there, minus 1. So we're looking where sine x is 0 or sine x is 1.
Yeah.
So we've either got where sine x is 0, which is, we're on radius this time, so that's got to be pi.
Yeah.
Because that's 2 pi.
Yeah.
Or where sine x is 1.
Yeah.
Which is pi by 2.
Yeah, yeah, these ones are just obvious, aren't
So
they?
x in this case is pi and x is pi by 2.
Yeah, because we weren't allowed to be 0 or 2 pi.
No.
Because it's strict inequalities there. So just the ones in between. So pi and pi by 2. Excellent. Let's try the next one.
Oh. Okay. Well, I've got sines here, well, sine here basically. So, and I can't do anything to convert that into a cos.
No, because sine x isn't.
No, 1 minus cos x, but cos squared x is 1 minus sine squared x.
Yep.
So let's do that.
Okay.
Right, I'm going to multiply everything by -1.
Okay.
Well, I'm going to collect together my terms as well. Yeah. So sine squared x plus sine x minus 2.
Yeah. And now it's looking like that first one we did.
It's looking
Will it
like that first one.
factorise?
I hope so. Sine x, we've got plus 2 minus 1, 0. So sine x is 1. Again, you could inverse sine, or sine x is minus 2. That's another impossible one, isn't it?
Yeah.
Because if that's the case, that's going to be -1.
Yeah.
That one's -2,
Yeah.
which is not graph as opposite.
Yeah.
So that's impossible. This one is where sine x equals 1.
Yeah.
And we're looking between 180 and -180.
Yeah. Always worth looking at where you're looking for solutions. And there's only one still.
Yeah.
But it
yeah.
might have picked up another one.
So that one is at 90.
Yeah.
So x is 90.
Yep. Okay. No squares here.
No squares
But
here.
we have got the rule. Sine x over cos x is tan x. Now,
Okay, yeah. So if I divide everything by cos x,
Yep.
yeah?
Yep.
So divide that by cos x, that's going to give me a tan, which is nice. Divide that by cos x,
That'll
that's gonna-
cancel.
and 0 divided by cos x is still
0.
0. So I've now got tan x minus 4 is 0. So tan x is 4.
Yep.
I think that's probably going to be a moment where I need to,
Are we in degrees or radians?
we're in degrees.
Okay, so I'll go tan minus 1 of 4, yeah?
Yeah.
That is 75.96.
25.96.
Well, to 2 decimal places. Oops.
Yeah.
Yeah, so the tan graph does that, doesn't it? And then, but I can just do this on the calculator, can't I? So I'll do option, calc, solvent, tan, what is it? Tan x equals 4. And that gives me,
Should be 2 solutions, I reckon.
it's having a think. It's having, oh, there we go. So negative, 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 negative. Where are we? 0 to 360.
Yep.
Yeah, first one is 75.963.
Yep.
And the next one's 255.96. And the next one is 435, so that's too big.
Yeah.
Yeah, so they're the solutions.